Approximating trig functions. Well, believe it or not, we're going to start with a clock. Imagine it's an old-fashioned clock and it's got hands. And the hands could go from 12 o'clock to 1 o'clock. So that would be 1 hour. Well, 1 hour could be broken down into minutes. 1 hour is equal to 60 minutes. And every minute can be broken down into 60 seconds. You might be thinking I'm teaching the wrong class right now, but believe it or not, this has to do with trigonometry. So if you have, I'm not drawing this to very accurately, but suppose that this was 1 degree. So for me to actually draw 1 degree would be so tiny, I couldn't really draw the 1 degree in there. But anyway, suppose that that's 1 degree. Well, that 1 degree can be broken up into 60 minutes. So break this up into 60 tiny pieces. Okay, you get the idea. Break it up into a whole bunch of pieces, and each one of those is a minute. And then each one of those tiny ones can be broken up into seconds. So 1 degree is equal to 60 minutes. And you could write the word minute, or you could put this as a shorthand. So 1 degree equals 60 minutes. And 1 minute is equal to 60 seconds. And you could write the word seconds, or you could use the shorthand with the double primes. So these are called primes. So this is standing in trigonometry anyway. This is standing for minute, and this is standing for second. Now, for example, convert 23.6 degrees to degrees, minutes, and seconds. And again, you could write out degrees, minutes, and seconds, or use this abbreviation DMS. Well, basically this 23 degrees could be written as 23 degrees plus a decimal part. So this part, that's already the degrees, that's done. Now, how many minutes? Well, this is basically saying it's a fraction of a degree. So if you take this and multiply that every 1 degree is 60 minutes. So if you multiply by that conversion factor that's right here, then degrees and degrees will cancel out. And so then it's going to be in seconds. So this would be 23 degrees plus 36, I believe. How much is a 0.6 times a 60? It's 36. Now technically you could leave it like this with the plus in between, but usually it's written like this: 23 degrees and 31 minutes. And since there was no decimal here, there's no seconds. So even though it says degrees, minutes, seconds, if there's no seconds, you just leave it like that. Now let's try one that is a little more challenging. So now convert 46.73381 degrees to degrees, minutes, and seconds. So you just take off the whole number part, that's going to be degrees. Then you take the decimal part and you multiply by 60. And then this is going to be in minutes. So really I just need to know what's the decimal part, 0.73381 times 60. turns out to be 44.0286. So 44.0286, and now this part's in minutes. And now we'll take off the 44, so 46 degrees plus 44 minutes plus, take the decimal part, oops, I forgot a 0, and multiply that by another 60. So now just take the decimal part, 0.0286 times another 60, and then that's how many seconds. And because we don't go to microseconds or milliseconds, you just stop right there and write that down. So it'd be 46 degrees plus 44 minutes plus, then it was 1.716 seconds, or 46 degrees 44 minutes and 1.716 seconds. So now I just want to try something. Usually I just do it this way, but you can on the calculator go like this. At least in theory. Let's see if the calculator will work with me. So I go to the original problem, and then right here in blue it says angle. So put second angle. And then number 4, we'll change it to degrees, minutes, and seconds. So the arrow means change something to degrees, minutes, seconds. And let's see if it does it. Oh, nice job, calculator. So there's just a little bit of, no, it's not rounding error. That's me writing the wrong. Good thing I checked my answer. This ends with a 6. Okay, now work the other way around. So for example number 3, convert, let's go with 6 degrees, 17 minutes, and 32 seconds to decimal form. Well, when you're converting to degrees, minutes, seconds, you multiply by 60. When you're going the other way around and converting to decimal form, you divide by 60. So this will be the whole number 6, and then 17 needs to be divided by 60 to change it to degrees. And then for the seconds part, it needs to be divided by 60. That would change the seconds into minutes. Now to change this, which is in minutes, into the decimal part, you have to divide by a 60 again. So 160 changes it from seconds to minutes. The other 60 changes it from minutes to degrees. And now all of this is in degrees, so I just need to type it in the calculator and see what the decimal is. So a 6 plus 17 divided by 60, and then a 32 divided by, because there's more than one number, I should put it in parentheses. A 60 times a 60. So that would be 6.2922, and the 2's go on forever. Now to check that answer, I could do what I just did. Go to second angle, change it to degrees, minutes, and seconds, and it's 6:17:32. So this is correct. All right, now this section is called Approximating Trig function, so now we need to use that new idea of the degrees, minutes, and seconds. And for example number 4, use a calculator to figure out how much is cosine of 17 degrees, 4 minutes, and 39 seconds. So one way to do this is, like I just did in the last one, you convert this to a decimal form. So first of all, this would be 17 degrees, and then the 4 needs to be divided by 60, and the 39 needs to be divided by 60 twice. Or you could just put 3600 right here. And now these have been converted to degrees. So that would be a 17 plus a 4 divided by 60 plus a 39 divided by 60 times 60. 60 times 60. So that's 17.0775. And then we're supposed to find cosine of that. So right now my calculator's in degrees. That's good. And then find out what is cosine of 17.0775. So it's 0.9559, and that's enough decimals. Actually, I prefer to work with 3 decimals, so from now on, I'm going to use 3 decimals. Now I'm wondering if the calculator can do this directly. I'm really not sure, because I just do it this way myself. But let's see if I could do it on the calculator. So what I'll have to do is look at the angle stuff. Ooh, the problem is it doesn't have seconds in here. It has degrees and it has minutes, but it doesn't have this little thing. Oh well, that's okay. I already got the right answer. Okay, then on to the next part. Example number 5. Compute cosecant of negative 111 degrees 12 minutes. Okay, so first the negative 111, and the negative applies to the whole thing, so I'm just going to factor out the negative and put brackets. And then plus 12 needs to be divided by 60. So figure out that part first. So there's a negative that's factored out, and then it's 111 plus 12 divided by 60. I said plus. Thank you. So negative 111.2. Negative 111.2, that's in degrees. Now for cosecant of negative 111.2. So since my calculator doesn't have cosecant, I need to use the trig identity. You guessed it, the 3x5 card, that cosecant is equal to 1 over sine. So then I need 1 divided by sine of negative 111.2. And it equals negative 1.073. So I prefer to work with 3 decimals all the time and just leave it as 3 decimals. When you're doing online homework, it may say, for one problem, round this to 2 decimals. So change the mode, change it to 2 decimals. It may say, and it usually says it right where you're supposed to type in the answer. It may say, hey, use 5 decimals. So change the mode to 5, second quit. If I put second enter, it gives me the last problem back again, and then I've got 5 decimals. So just be aware with the online homework that you may need to do that. Okay, now to the last part of this section. Something extremely helpful, inverse trig functions. So I'll show you with an example. Example number 6. Suppose that sine of theta is equal to a 0.57. So then what does theta equal? Well, you could try guessing and checking and go sine of, I don't know, 35. Oh man, did you see that? That was just a guess. I got really close. So anyway, this is a little bit too big, so maybe I should have guessed 34. No, it's got to be between 34 and 35, so 34.5. Nope, 34.8, 0.5. Oh, that's really close. It has to be a little bit smaller. 34.777. So anyway, I'm getting close. The answer should be 34.7 something. Well, guessing and checking takes too long, so there's a fast, easy way to do it. And that is you take sine inverse of both sides. So this is just like in algebra, if you had e to the x equals 4. Well, the inverse function of e is the natural log. So you would take the natural log of both sides. These two cancel each other out. And then it would leave you x equals the natural log of 4. So ln and e are inverse operations. And if you look on the calculator, right here, the ln and the e are right next to each other because they're inverse operations. The same right here, square and square root. Plus and minus are next to each other. Multiply and divide, so all the inverse functions are next to each other. So sine and its inverse are right next to each other. So you would just need to use second sine inverse. On this side, these two cancel out. And then it just says find sine inverse of a 0.57. With my guess and check, I saw that it was approximately 34.7, but what is the actual answer? It's 34.75023. You know what? Let me change it back to 3 decimals. Thanks. Okay, so second enter to redo it. So 34.750. And then that's in degrees. So you could even use that for examples like this. Suppose that this building is 110 feet tall. And then suppose that a person was standing over here 130 feet away. And then they look to the top of the building, and what's this angle of elevation? So solve for theta. This was supposed to be in feet, in feet. So since this is a right triangle, then we could use opposite over adjacent. So that means tangent. So tangent is opposite over adjacent. So a 110 over a 130. And I would usually say reduce your fractions, but we're just going to type it in the calculator, so you could leave it like that. Then take tangent inverse of both sides. These will cancel, leaving just theta on the left side. And then ask the calculator, what's tangent inverse of 130? So second tangent inverse, a 110 divided by a 130, and it's 40 point theta equals 40.2 236 degrees. And then if you needed to, you could go to second angle, change it to degrees, minutes, and seconds. Or you could be all fancy and write, that's 40 degrees, 14 minutes, and 10.89 seconds. Okay, now there's still one other important idea with using sine inverse, cosine inverse, and tangent inverse. Actually, there's two more ideas. So how about this? Secant equals 9/5 and then solve for theta. Well, as you know, this calculator only has sine, cosine, and tangent. It does not have secant, it does not have secant inverse. So the first thing that we need to do is change this to be 1 over cosine. Okay, that's the identity for secant. Now, invert this side so it becomes cosine over 1. But if you invert one side, you need to invert the other side, so the right side will become 5 over 9. All right, we're almost done. Then take cosine inverse of both sides. These cancel, leaving just the theta. And then find cosine inverse of 5/9, and that would be 56.251 degrees. There you go. Okay, now we're down to the last extremely important idea, and that is if I just change the question slightly, suppose that sine of theta is equal to 1/3. Then find all of the solutions between 0 and 360 degrees. So each one of these will actually have two solutions. If you're asked for the solutions between 0 and 360, then it will always have two solutions. The reason is a smart trig class tells you when they are positive. This problem right here is saying sine equals a positive 1/3. Well, sine could equal a positive in this quadrant or in this quadrant. So there's going to be two solutions. When you use sine inverse on the calculator, it tries to give you the smallest solution or the one closest to 0. So take sine inverse on both sides. And you could write down this step with the red part, cosine inverse, and then have them cancel. Or you could just skip to that part. Theta equals cosine inverse, or theta equals sine inverse of the fraction. So what does the calculator say about that? Sine inverse of 1/3. And it gives me the smallest answer. So it's giving me the answer in quadrant 1, 19.471 degrees. So it's basically saying I found this solution, 19.471 degrees. So that's taking care of this one in quadrant 1. But if you take this angle and you flip it over into quadrant 2, it would look like this. 19.471 degrees got flipped over into quadrant 2. In which case, if you go from here to here, that's another solution for the theta. And this red angle would be 180 minus the 19.471. So 180 minus 19.471 is 160.529 degrees. So we now have the two solutions. And I should be able to plug either solution in right here, and the answer it will give me is a third. Let's see. Take sine of 19.471. Does that equal a third? Yep, 0.3333. What about sine of 160.529? Yep, 0.3333. Excellent. Now let's just do one more, like if it was equal to a negative. Example number 10. I think this is the most examples I've done for a section so far. It's like a record. So let's say tangent of theta is equal to a negative 1.7. Then find the two solutions. A smart trig class tells you when they are positive. Now this one is saying tangent equals a negative. So tangent's positive here, and they're all positive here. So in other words, there would be two solutions, one in the second quadrant and one in the fourth quadrant. Now what happens when you take tangent inverse of a negative? Let me write that part down. Theta equals tangent inverse of negative 1.7. So I'm going to make a mistake right now, and you tell me what I did wrong. Did you catch it? The problem is you have to use this for negative. This is for subtracting two numbers. This is for having a negative. That's what the calculator is complaining about. Put the cursor right there, says, I don't like that. Put a negative. Okay. And the calculator gives us the answer that theta equals negative 59.534 degrees. Now I want two positive answers. The calculator said if you go this direction, the negative direction, then that will be 59.534 degrees. But I want to know what would theta be if you went from here around to here. So that would be that theta equals 360 degrees. That would be all the way around the circle. And now just subtract out this gap, the red gap. So minus 59.534 degrees. So 360 minus 59.534 is 300.466 degrees. So that's the solution in the fourth quadrant. Now what about the second quadrant? So what I could do is take this 59 degrees, basically just take this red picture right here and flip it over into this quadrant. Or in other words, this is going to be the angle, and then this is the 59.534 degrees. Now to get that, you start from the x-axis and you go this direction so that you have a positive answer. And that means that it would be theta equals 180 minus the 59.534. So now a 180 minus 59.534 is a 120.466 degrees. So I'm going to check that answer. I'll take that 120.466, I'll plug it in and find tangent of it, and it should equal a negative 1.7. Tangent of 120.466, and it should equal a negative 1.7. Yay, good job, math. I love math.